Hello everybody, welcome to the third trig video in this Ashbourne Maths video series. This is the third video and we're going to solve an equation today that looks kind of like in the form of this. This is kind of quite a typical question that you might see. Now again, our problem is that we've got a mixture of trigonometric functions. We've got a cos squared of x and we've got a sine of x here, okay? So there's a mixture, that's a problem. And what we're going to do is we're going to try and get it in a form so that we have only sine squared x's, sine x's and constants, okay? So again, only sine x, but this time we're going to have a sine squared x as well as just a normal sine x in the same equation. So our first task is we've got to change this cos into a sine, otherwise we can't deal with it, okay? Now, you should remember, like the back of your hand, our trig identity, sine squared x plus cos squared x, is the same as what? It's the same as 1. And we're going to rearrange this. This is going to help us. So we're going to get, okay, I've just taken away sine squared x from both sides. So going back to my equation, and we're going to make the substitution. So I'm going to substitute in this cos squared x using my identity. Okay, so I get 4. So this implies that 4, making the substitution, so 4 lots of 1 minus sine squared x instead of the cos squared x, plus 7 sine x minus 2 equals 0. Let's expand that bracket. 4 sine squared x plus 7 sine x minus 2. And then let's just simplify. So I get 4 minus 4 sine squared x plus 7 sine x plus 2 equals 0. Okay, and I've kind of done what I intended to do. Do you remember at the start of the video I said we wanted to get this equation into a form so that's only got sines, okay? But admittedly, we do have some sine squareds and some sines, a mixture of the two. We cannot just add these two together, right? It doesn't just become 3 sine squared x or 3 sine x. That's not correct. So what do we do with this? Well, this is where we do a clever little thing. So if I say sine x equals capital Y, okay, just making up a new variable, then I now have minus 4 lots of, well, sine squared of x is the same as y squared, right? This is the same as y squared. And plus 7 lots of, well, sine x is just, that's just y now. Plus 2 equals 0. And now, I hope that you can spot that this thing is a quadratic. Okay, so what we've done is we've got a quadratic in sine of x, okay? And we've changed the variable so it looks a bit more familiar to us. And now we just need to solve this thing, right? We know how to do this. Now, hopefully, your first move on this will be the same as mine. Just pause the video and see if you can spot what you do first. Okay, now I hope that you would times everything by minus 1, okay? Because we want to get our y squared term as a positive, okay? That's just going to help us. So 4y squared minus 7y minus 2 equals 0. And then I can factorise this, okay? 4y plus 1 and y minus 2 equals 0, okay? And so this implies that y equals either minus 1 over 4 or y equals 2. Which implies, now I can bring back my substitution now, okay? Because I know that y is just the same as sine x. So this means that sine x is the same as minus 1/4, or sine x is the same as 2, okay? So these are my two solutions. Okay, so hopefully you've spotted what I've done. I made it into a quadratic. I solved the quadratic, and then I went back and changed it back into sine x instead of y, okay? Quite a clever little move. I hope you will agree. Now, which of these two solutions am I going to take? One of them is not going to work for me. Again, pause the video, try and work out which one you think is not going to work. Now, it is this one, sine x equals 2. That is not going to work. Why? Because, well, let's just remember our sine x graph. This is sine of x. And you remember it goes between 1 and minus 1, right? 1 and minus 1. So sine of x equals 2. It's too big. It will not work, okay? So this one here is not good, okay? So we're left with sine of x equals minus 1/4. And we're just going to solve this in our normal way, okay? So let's use our Rams method again. So what's the range? Well, it's between 0 and 360 degrees. So my range is x between 0 and 360 degrees. Okay, the angle. So angle number 1, I just do this on my calculator. Inverse sine of minus 0.25, which is the same as minus a quarter. And I get that x equals minus 14.5. Okay, next is more. So angle 2, do you remember for sine, I just do 180 minus whatever angle 1 was. So this is 180 minus my first angle, and I get 194.5 degrees, again to 1 decimal place, always write that. And what about a third angle? Well, we need, again, we just do angle 1 or angle 2 plus or minus 360 degrees. Yeah, hopefully you remember that. Now, my angle 1 was minus 14.5, so let me add 360 degrees to that, because that's going to be in our range as well, isn't it? This is going to be 345.5 degrees, and that's 1 decimal place. And if I add 360 degrees to my second angle, that's going to be too big. If I take away 360 from my second angle, that's going to be too small. So I think I've actually got my 2 solutions. And just thinking about the range, remember this first solution, this one here, is actually not in the range, is it? So I'm going to discount that. Okay, so what are my solutions? My solutions are x equals 194.5 degrees and 345.5 degrees. And I've done the question. Finished. And highlight if you're feeling particularly helpful. Okay, the last thing I just want to mention in this video is a couple of other quadratic options that you might see. Okay, so this is my kind of like first example of what we're calling a quadratic in sine of x. Okay, this is called a quadratic in sine of x. And you now know how to solve that. We did this, we used the substitution, didn't we? We substituted for y and we had a quadratic in y. That's capital Y, by the way, okay? Capital Y. Okay, let's just touch on another couple of examples. So you might see something like this. 4 cos squared x minus cos x equals 0. Okay, now again, if we make that substitution, y equals cos of x this time, then we're going to have 4y squared minus y equals 0. Okay, now again, this is a quadratic. It's got a term that's got a square. The highest power of this is a squared, so it's a quadratic. But this is a bit easier to solve, isn't it? I don't need to factorise with double brackets. I can just take a factor of y out. So I get y, open brackets, 4y minus 1 equals 0. And this tells me that y equals either 0 or y equals 1 over 4. Okay? Be careful. Please, please be careful. I think a lot of people would say, looking at this line, say, I just divide by y. Okay, you can't do that. You must take out a factor of y. Okay, because why? Well, because you're dividing by 0, potentially, which is not good. Type 3 is if we've got something that looks potentially like this. So I've used a different trigonometric function, but the principle stays the same, whether it's sine or whether it's cos. It's the same principle, okay? Y equals tan of x this time. So then I'm left with 9y squared minus 16 equals 0. Okay, pause the video. What would you do here? Hopefully you've noticed that this thing, really important you spot this. This is the difference of 2 squares. Okay, you've got to start spotting that if you haven't, okay? Always be on the lookout for a difference of 2 squares. And just note that there's no y term here, is there? So it's like the difference, the one I've just written there, is this has got just a y term, but we don't have that in this example. It's just the y squared term minus the unit term, okay? And we've got a way to factorise this out. This becomes 3y, sorry, not plus 16, 3y plus 4 and 3y minus 4 equals 0. And so we have our solutions of y equals minus 4 over 3 and y equals 4 over 3. Okay, those are our solutions. So just bear in mind those 3 different types of quadratics that will arise and that you need to be comfortable with solving. Okay guys, that's the end of the video. Thank you very much.